Hi, and welcome once again to day 21 of Just Start Programming, the Rust programming language. We have made it together. It has been quite a while since I started this live programming series, where I myself also started from scratch, not knowing anything about Rust. Today, we will learn more about cargo and crates.io. So join me once again, do it live in one take. No shortcuts and no secrets. Well then, let's just start programming. Okay, so here we are. More about cargo and crates.io. So what do we have here? So far we've used only the most basic features of cargo to build, run, and test our code. But it can do a lot more. In this chapter, we'll discuss some of its other more advanced features to show you how to do the following. Customize your build through release profiles, publish libraries on crates.io. Crates.io, let's open this one. Okay. So it's like a repository of crates. Organize large projects with workspaces. Install binaries from crates.io. Extend cargo using custom commands. Cargo can do even more than the functionality we cover in this chapter. So for a full explanation of all its features, see its documentation. So there's a separate documentation. The cargo book. I think we have glanced through this in the early chapters. Or anything specific here? It's all about crates and cargo. Okay. Let's start this chapter. Customizing builds with release profiles. In Rust, release profiles are predefined and customizable profiles with different configurations that allow a programmer to have more control over various options for compiling code. Each profile is configured independently of the others. Cargo has two main profiles, the dev profile, cargo uses when you run cargo build, and the release profile, cargo uses when you run cargo build -- release. The dev profile is defined with good defaults for development, and the release profile has good defaults for release builds. These profile names might be familiar from the output of your builds. Cargo build, finished dev profile, unoptimized, plus the debug info. Cargo build release. So here you will see it's a release profile. The dev and release are these different profiles used by the compiler. Cargo has default settings for each of the profiles that apply when you haven't explicitly added any profile.asterisk sections in the project's cargo.toml file. By adding profile.asterisk sections for any profile you want to customize, you override any subset of the default settings. For example, here are the default values for the opt level setting for the dev and release. Opt level, what does it mean? Opt level 0, opt level 3. Okay. The opt level setting controls the number of optimizations Rust will apply to your code with a range of 0 to 3. Applying more optimizations extends compiling time. So if you are in development and compiling your code often, you want fewer optimizations to compile faster, even if the resultant code runs slower. The default opt level for dev is therefore 0. When you're ready to release your code, it's best to spend more time compiling. You'll only compile in release mode once, but you'll run the compiled program many times. So release mode trades longer compile time for code that runs faster. Okay. That is why the up level for release is profile 3. So in release, you wanted the code to run faster, but while compiling, it takes longer time. You can override a default setting by adding a different value for it in cargo.toml. For example, if you want to use optimization level 1, in the development profile, we can add these two lines to our project's cargo.toml file for that. Okay, so here it increased the optimization level. This code overrides the default setting of 0. Now when we run cargo build, cargo will use the defaults for dev profile plus our customization for op level. Because we set op level to 1, cargo will apply more optimizations than the default, but not as many as in release build. For the full list of configuration options and defaults for each profile, see cargo's documentation. So what's in 0, what's in 3, what's in 1? Profiles. Okay, up level 1, use slightly better optimization. 1, basic optimization. What's in basic? Debug profile. Okay. Default settings for the dev profile. Oh, so there are other settings also. Debug true, split debug info, strip none, debug assertions. Okay. But what is in profile 1? Maybe there will be some information here for profile 1. Okay, let's come back to this one. Okay. Publishing a crate to crates.io. We've used packages from crates.io as dependencies of our project, but you can also share your code with other people by publishing your own packages. The crate registry at crates.io, okay, so this one, distributes the source code of your packages, so it primarily hosts code that is open source. Rust and Cargo have features that make your published package easier for people to find and use. We'll talk about some of these features next and then explain how to publish a package. Making useful documentation comments. Accurately documenting your packages will help other users to know how and when to use them. So it's worth investing the time to write documentation. In Chapter 3, we discussed how to comment Rust code using 2 slashes. Rust also has a particular kind of comment for documentation, known conveniently as a documentation comment, that will generate HTML documentation. The HTML displays the contents of documentation comments for public API. items intended for programmers interested in knowing how to use your crate as opposed to how your crate is implemented. Documentation comments uses the 3 slashes, 2, 3, instead of 2 and support markdown notation for formatting the text. Place documentation comments just before the item they're documenting. Listing 14-1 shows documentation comments for an add1 function in a crate named myCrate. Okay, so what do we have here? Source lib.rs, add1, there's triple slash, adds 1 to number given, examples, there's this backtick. I think this is for the code. Okay. Here we have a description of what the add1 function does. Start a section with the heading examples and then provide a code that demonstrates how to use add1. Okay. We can generate the HTML documentation from this documentation comment by running cargo doc. This command runs the Rust doc tool distributed with Rust and puts the general HTML documentation in the target doc directory. For convenience, cargo doc --open will build the HTML for your current crate's documentation, as well as the documentation for all of your crate's dependencies, and open the result in a web browser. Navigate to the add_1 function and you'll see how the text in the documentation comment is rendered as shown in 14-1. Adds 1 to the number given, examples. Commonly used sections. Okay, maybe let's try this one. So, close this. Let's leave mini graph, and in here we do a cargo new more cargo. It's always good to test if it's able to compile. Okay. We have lib.rs. Oh, then we should have done the --lib. Can we still do that? Cargo new more cargo. Maybe let's do it again. rm-fr more cargo. So this is just to delete the entire more cargo directory. We do a cargo new more cargo --lib. Okay, so we have add. Okay, never mind. Just keep it as it is. Adds 1 to a number given. Okay, let's copy this and put it here. Maybe let's change this to add 1. Here, add 1. And we remove this one. And we change this to 3. And let's put 1. Add 1. Let's try running the test. Of course, it will pass. And then here we have a small documentation. So what was the command? Cargo doc open. Cargo doc open. And let's come back here. And I'm under more cargo. I'll put cargo doc open. So let's do a tree. Should have doc. Oh, it opened index.html also. Adds 1 to the number given. Fn add 1. U64. Here is the example. Nice. Okay. So it was able to generate the documentation. Okay. So we'll see similar to this. Yeah, instead of I32, ours is 64. Was it U64? Yeah, 64. That's the only difference. Add 1 function. Add 1 creates my crate. And okay, so this one is under more cargo. In crate more cargo functions and okay, so it looks like that. Okay, commonly used sections. We use the sharp examples markdown heading listing 14-1 to create a section in the HTML with the title examples. Maybe it's worth looking into markdown also. Markdown online. Maybe let's use this. Markdown live preview. Nice. So sharp will be, I think this is heading 1. No, heading 1. This is heading 1. Yeah, heading 1. Correct. So that one created a heading. Examples. Here are some of other sections that Crate authors commonly use in their documentation. Yeah, panics. The scenario in which the function being documented could panic. Callers of the function who don't want their programs to panic should make sure they don't call the function in this situation. Errors. If the function returns a result, describing the kinds of errors that might occur and what conditions might cause those errors to be returned can be helpful to callers so they can write code to handle the different kinds of errors in different ways. Safety. If the function is unsafe to call, we discussed unsafety in chapter 20. There should be a section explaining why the function is unsafe and covering the invariants that the function expects callers to uphold. Most documentation comments don't need all of these sections, but this is a good checklist to remind you of the aspects of your code users will be interested in knowing about. It would be nice if you have like a macro that will generate these things automatically. Oh, there's this run doc test. What does it do? Migrate. Use cargo, add migrate to add it to your cargo. Toml. Okay. Documentation comments as test. Adding example blocks in your documentation comments can help demonstrate how to use your library, and doing so has an additional bonus. Running cargo test will run the code examples in your documentation as test. Nothing is better than documentation with examples, but nothing is worse than examples that don't work because the code has changed since the documentation was written. So it means you need to update your examples also. If we run cargo test with the documentation for add-on function from listing 14-1, we will see a section in the test results like this. Cargo test. Doc test. This is doc test. How is it different from this one? Cargo test. It's the same. Now if we change either the function or the example, so the assert equal macro in the example panics and run cargo test again, we see that the doc test catch that the example and the code are out of sync with each other. Commenting the contained items. What is here? Either the function or the example. And linked crate migrate. What did it say? Either the function or the example, so assert equals in the example panics and running it. We'll see the doc test catch the example and the code are out of sync with each other. In the example panics. Okay, so let's try 2 doesn't become 3. Let's make it 4. So it will panic. Cargo test. What does it say? Where's the cargo test? Steady out failures. Okay, running one test. Okay, we did the cargo test here, running one test. Test, it works, okay. One pass. Running one test. Leave.rs, add one, failed. Line 5. Failures, failed to resolve the use of unresolved module. Okay, okay, that is fine. Aborting due to one previous error. Couldn't compile the test. Failures, add one, line number 5. Doc test failed to rerun pass dash dash doc. Oh, there's something here. Failures, test, it works, test out. It works, panic. Left equals right, fail. Left is 3, right is 4. So it panicked. So it was able to detect. Did it change anything here? No, it did not change anything. At least it knows. We'll see that the doc test catch that the example and the code are out of sync with each other. Example and then the code. Where did it say example? Add one. What did we have there? It's not migrate. It should be more cargo. More cargo. What happened to this? Module or unlinked crate. It's in the cargo.toml. Let me see. Did it complain anything about the example? Oh, now here there's no more error. Okay, commenting contained items. The style of doc comment / exclamation mark adds documentation to the item that contains the comments rather than to the items following the comments. We typically use these doc comments inside the crate root by convention or inside the module to document the crate or the module. For example, to add documentation that describes the purpose of my crate, create crate that contains the add one function. We add documentation comments that start with / exclamation mark to the beginning of sourcelib.rs. In the beginning of sourcelib.rs. Sourcelib.rs. This is sourcelib.rs. So let's put it here. Okay, what will happen here? So I need to cargo the open my crate. A collection of utilities to make performing certain calculations more convenient. Is it that one? Yeah. Yeah, so now this is in the my crate. Under my crate. About here, more cargo. Oh, this was updated also. Yeah, because they're pointing to the same thing, the same file. Notice there isn't any code after the last line that begins with this one. Because we started the comments with / exclamation mark instead of / triple slash. We are documenting the item that contains this comment rather than an item that follows this comment. In this case, the item is sourcelib.rs file, which is the crate root. These comments describe the entire crate. When we run cargo doc open, these comments will display on the front page of the documentation for my crate. Front page. Where was it? Front page. Okay, so it's in the front page. Let's check summary. Unless it's here. Crate, my crate. Documentation comments within items are useful for describing crates and modules especially. Use them to explain the overall purpose of the container to help your users understand the crate's organization. Yeah, so we do something like this at the crate and module level. Exporting a convenient public API with pub use. Okay, so now we have API. The structure of your public API is a major consideration when publishing a crate. People who use your crate are less familiar with the structure than you are and might have difficulty finding the pieces they want to use if your crate has a large module hierarchy. In Chapter 7, we covered how to make items public using pub keyword and bring items into the scope with the use keyword. Oh, so that's why we have pub and use here. However, the structure that makes sense to you while you're developing a crate might not be very convenient for your users. You might want to organize your structs in a hierarchy containing multiple levels. But then people who want to use a type you're defined deep in the hierarchy might have trouble finding out that type exists. They might also be annoyed at having to enter use, okay, this one, rather than use my crate useful type. The good news is that the struct isn't convenient for others to use from another library. structure. You don't have to rearrange your internal organization. Instead, you can re-export items to make a public structure that's different from your private structure by using pub use. Re-exporting takes a public item in one location and makes it public in another location, as if it were defined in the other location instead. For example, say we made a library named Art for modeling artistic concepts. Within this library are two modules: kinds module containing two enums named primary color and secondary color, and a utils module containing a function named mix as shown in 14-3. 14-3, an art library with items organized into kinds and utils modules. We have here, so we have this main comment art, and you have the mods, which is kinds. Then you have this comment primary colors according to the red, yellow, blue. Red, yellow, blue or RGB, red, green, blue. Primary color. Okay, because it's primary color. Okay. Red, yellow, blue. The second colors according to the RYB color model. Second color. Orange, green, purple. Mod utils. Okay, so mod utils we use create kinds asterisk. This one combines two primary colors in equal amounts to create a secondary color. Okay, so here we have this comment for the function. Figure 14-3 shows that the front page of the documentation for this crate generated by Cargo Doc would look like. Create art, a library for modeling artistic concepts. Yeah, so this part. Okay, note that the primary and secondary color types aren't listed on the front page, nor is the mix function. You have to click kinds and utils to see them. Okay, kinds and utils. Kinds, okay, because you have this module, kinds and utils. Another crate that depends on this library would need use statements that bring the items from art into scope. Specifying the module structure that's currently defined in 14-4 shows an example of a crate that uses the primary color and mix items from the art crate. Okay. Use statements that bring the items from art into scope. Module structure that's currently defined shows an example of a crate that uses primary color and mix items from art crate. Okay, so primary color is under kinds and mix. What is mix? Mix items from the art crate. Okay. The author of the code in 14-4, which uses the art crate code, had to figure out that the primary color is in the kinds module and mix is in the utils module. The module structure of the art crate is more relevant to developers working on the art crate than to those using it. The internal structure doesn't contain any useful information for someone trying to understand how to use the art crate, but rather causes confusion because developers who uses it have to figure out where to look and must specify the module names in the use statements. To remove the internal organization from the public API, we can modify the art crate code in listing 14-3, add pub use statements to re-export the items at the top level as shown. Pub use. Okay, that is to remove the internal organization from the public API. We can modify the art crate in listing 14-3 to add pub use statements to re-export the items at the top level as shown. Okay. Library for modeling artistic concepts. Primary, secondary, then you have mix mod kinds. Okay, you have sub here. Adding the pub use statements to re-export items. Pub use, pub use, pub use. Okay. The API documentation that CargoDoc generates for this call will now list and link re-exports on the front page as shown in 14-4, making the primary color and secondary color types and the mix function easier to find. Where's the mix function? Okay. Re-exports, kinds, utils. The art crate users can still see and use the internal structure from 14-3. 14-3, this one. As demonstrated in listing 14-4. This is 14-4. Or they can use the more convenient structure in listing 14-5. 14-5. Okay. Creating a useful public API structure is more than an art than a science, and you can iterate to find the API that works best for your users. Choosing pub use gives you flexibility in how you structure your crate internally, and decouples the internal structure from what you present to your users. Look at some of the code in crates you installed to see if their internal structure differs from their public API. Okay, setting up a crates.io account. Before you can publish any crate, you need to create an account on crates.io. Okay, create an account. But we will not do it now. So I think here, log in with GitHub. If you have GitHub, then you don't need to create an account. Just GitHub account is currently a requirement, but the site might support other ways of creating an account in the future. Once you are logged in, visit your account settings at crates.io/me. Okay, after logging in, you'll see something there. And retrieve your API key. Then run the cargo login command and paste your API key when prompted like this. So you can do a cargo login. This command will inform cargo of your API token and store it locally in that cargo credentials. Note that this token is a secret Do not share it with anyone else. If you share it with anyone for any reason, you should revoke it and generate a new token. Okay. It means that we need to create a new token in our profile, creates.io/me. Okay. Adding metadata to a new crate. Let's say you have a crate you want to publish, but before publishing, you'll need to add some metadata in the package section of the crate's cargo toml file. Your crate will need a unique name where you're working on a crate locally. You can name a crate whatever you'd like. However, crate names on crates.io are located on a first come first served basis. Okay, do we have mini grep here? Let's check. Oh, there's already mini grep. There's so many mini grep. Simple implementation from the Rust programming book. Oh, so it's here. Interesting. Okay. Once a crate name is taken, no one else can publish a crate with that name. Before attempting to publish a crate, search for the name you want to use. The name has been used. You will need to find another name and edit the name field in cargo.toml. Under package section to use the new name for publishing like so. Package guessing game. Okay. Even if you have chosen a unique name when you run cargo publish to publish the crate at this point, you'll get a warning. It's the warning. Oh, so you have cargo publish. Okay. This results in an error because you're missing some crucial information. A description and license are required so people will know what your crate does and under what terms they can use it. In cargo.toml, add a description that's just a sentence or two because it will appear with your crate in search results. For the license field, you need to give license identifier value. The Linux Foundation software package data exchange lists the identifiers you can use for this value. For example, to specify that you've licensed your crate using MIT license, then add the MIT identifier. So you have package, name, license, you put it here. If you want to use a license that doesn't appear in the SPDX, you need to place the text of that license in a file. Include the file in your project and then use license file to specify the name of the file instead of using the license key. Okay, so here license key. We can replace that with license dash file. Guidance on which license is appropriate for your project is beyond the scope of this book. There are so many license. Many people in the Rust community license their projects in the same way as Rust by using a dual license of MIT or Apache. Oh, so you can have different licenses for your project. This practice demonstrates that you can also specify multiple license identifiers separated by or to have multiple licenses for your project. Okay, with a unique name, the version, your description, and a license added, the cargo.toml file for a project that is ready to publish might look like this. Also, you have the name, version. This is part of cargo.toml, so maybe let's take a look. What do we have here? Name, version, edition. Okay, how about here? Name, version, edition. Then you have the description. Then you have the license. Okay. So these are metadata. Okay. Publishing to crates.io. Now you have created an account, save your API token, chosen a name for your crate, and specify the required metadata. You're ready to publish. Publishing a crate uploads a specific version to crates.io for others to use. Be careful because a publish is permanent. The version can never be overwritten, and the code cannot be deleted. One major goal of Crates.io is to act as a permanent archive of code so that builds of all projects that depends on Crates from Crates.io will continue to work. Allowing version deletions would make fulfilling that goal impossible. However, there is no limit to the number of crate versions can publish. Okay. Run cargo publish. Okay, so publish is the command. Okay, cargo publish, updating crates IO index, guessing game. Oh, okay. This one is using the guessing game project. Congratulations! You've now shared your code with the Rust community, and anyone can easily add your crate as a dependency of their project. Publishing a new version of an existing crate. When you've made changes to your crate and are ready to release a new version, you change the version value specified in your cargo.toml file and republish. Okay, so since version is in cargo.toml, this is cargo.toml, you have version here. You have to republish. Use the semantic versioning rules to decide what an appropriate next version is based on the kinds of changes you've made. The run publish to upload new version. Then run cargo publish to upload the new version. Okay. Deprecating versions from crates.io with cargo yank. Okay, so yank. Although you can't remove previous versions of a crate, can prevent any further projects from adding them as new dependency. This is useful when a crate version is broken for one reason or another. In such situations, cargo supports yanking a crate version. In this case, there's only one mini grep. The rest are mini grep underscore. Yanking. Yanking a version prevents new projects from depending on that version, while allowing all existing projects that depend on it to continue. Essentially, a yank means that all projects with cargo.lock will not break. Any future cargo.lock files generated will not use the yank version. Okay. Mm. So yank, so it's like yank, you yank it out. To yank a version of a crate, the dictionary, no, the directory of the crate that you previously published, run cargo yank and specify which version you want to yank. Oh, okay. For example, if we published a crate named Guessing Game version 1.0.1 and we want to yank it in the project directory for Guessing Game, we'd run cargo yank version 1.0.1, updating crates.io index, yank Guessing Game. By adding dash dash undo to the command, you can also do a yank and allow projects to start depending on a version again. Dash dash undo. Okay, so yank version 101 dash dash undo. A yank does not delete any code. It cannot, for example, delete accidentally uploaded secrets. If that happens, you must reset those secrets immediately. Okay. Next topic, cargo workspaces. So in chapter 12, we built a package that include a binary crate and a library crate. Yeah. In this case, it's also, oh no, it's only lib.rs. But of course, you can include a main.rs here. Hello world. Okay, continue. So we have binary crate and library crate. As your project develops, you might find that the library crate continues to get bigger, and you want to split your package further into multiple library crates. Cargo offers a feature called workspaces that can help manage multiple related packages that are developed in tandem. Okay, so how do we create workspaces? A workspace is a set of packages that share the same cargo.lock and output directory. Let's make a project using workspace. We'll use trivial code so we can concentrate on the structure of the workspace. There are multiple ways to structure a workspace, so we'll just show one common way. We'll have a workspace containing binary and two libraries, a binary and two libraries. The binary, which will provide the main functionality, will depend on the two libraries. One library will provide an add one function and other library an add two function. These three crates will be part of the same workspace. Let's start by creating a new directory for the workspace. Okay, make dir add cd add. Where do we put that one? Can we put it here? mkdir at cd add. Then here, what do we need to do? Next, in the add directory, we create the cargo toml file. Oh, in the add directory, we can create this one. In the add directory, yeah, so in the add directory. Okay. This file won't have a package section. Instead, it will start with a workspace section that will allow us to add members to the workspace. We also make a point to use the latest and greatest version of Cargo's resolver algorithm in our workspace by setting resolver to 3. Okay, let's copy this one. And here, where's the cargo.toml? Under add. Workspace resolver equals to 3. Okay, so that is added. Next, we'll create the adder binary crate by running cargo new adder within the add directory. So you can also do this within directory. Add directory, cargo new, adder. So cargo add under add, you have new adder. Adding adder as a member of workspace. See, adding adder as a member of workspace. Okay, so it's a workspace under more cargo. Okay, then the resolver, does it change? Resolver 3. Okay, running cargo new inside the workspace also automatically adds the newly created package to the members key. Okay, members. A key in the workspace definition in the workspace cargo.toml. At this point, we can build the workspace by running cargo build. The files in your add directory should look like this. Okay, so it's splitting it up, then under add, or what is it, adder subdirectory, you have your own cargo here, cargo.toml. Yeah, here cargo.toml, source main address. The workspace has one target directory at the top level that the compiled artifacts will be placed into. The other package doesn't have its own target directory. Even if you run cargo build from inside the other directory, the compiled artifacts will still end up in add target. Okay. Rather than add adder target. Cargo structures the target directory in the workspace like this because the crates in the workspace are meant to depend on each other. If each crate has its own target directory, Each crate would have to recompile each of the other crates in the workspace to place the artifacts in its own target directory. By sharing one target directory, the crates can avoid unnecessary rebuilding. That was quite long. It was a long read. Creating the second package in the workspace. Next, let's create another member package in the workspace and call it add1. Generate a new library. Create name add1. Okay, so there is. Okay, so the project is add library add1 package. Add1 is a member of workspace add. More cargo add. Add projects add. Okay, so where is it now? Add1. Okay, so add1 is here with librs. I think this should be add1. The top level cargo.toml will now include the add1 path in the members list. Okay, so cargo toml top level cargo toml. Nothing has changed here. Here. Adder add1 adder. Your add directory should now have these directories and files. Main cargo have add1 and adder. It will have its own cargo toml, source librs, source main rs. So there's add1 and then there's adder. Add1 and then there is adder. Okay. File name add1 source librs. Okay, so if we copy this, we go to add1 source librs. Add1 source librs. So we need to add this one, add1. Okay. Now we can have the other package with our binary depend on the add1 package that has our library. First, we'll need to add a path dependency to add1. On add1 to adder cargo toml. Adder cargo toml. Is it this one? Okay. Adder cargo toml. Adder cargo toml. Yeah. Then what do we need to do? Dependencies. Add1. Okay, so dot dot comes out from this one, and then it goes up to add1. Yeah, so that's how we That's how we are dependent on add one. So from our adder, you come up. So you have add one. Okay, so we stop here. That is for add one. Cargo doesn't assume that crates in a workspace will depend on each other. So we need to be explicit about the dependency relationships. Next, let's use add one function from the add one crate in the adder crate. Open the adder source main rs. Do we have it? Adder source main rs. Okay, we have hello world here. So instead of that, okay, we copy this here. Delete. So add one. In the cargo.toml, add one points to dot dot slash add one here. And then number. Okay, so it looks okay. Let's build a workspace by running cargo build on in the top level add directory. Top level add directory. Okay, so for us it's not called add. It's more cargo. So what we need to do, cargo build. Cargo build. Finished. Okay. To run the binary crate from the add directory, we can specify which package in the workspace we want to run by using -p argument and a package name with a cargo run. -p is the argument. So -p is the argument and the package name. Which package? Okay. So if you do it here, adder not found in workspace. Rest more cargo. Cargo build was executed in the top level add directory. So add one, we have add one. So it's add projects and cargo build. Let's try it from add cargo build. Cargo run p adder. Should be here. No, it's not in the scope. So so that one work. Hello world, 10 plus 1 is 11. What is P again? P is the package. Okay. Okay. Depending on external package in the workspace. Notice that the workspace has only one cargo lock file at the top level, rather than having cargo lock in each crate's directory. This ensures that all crates are using the same version of dependencies. If we add the rand package to the adder cargo toml and add one cargo toml files, cargo will resolve both of those to one version of rand and record that in the one cargo lock. Okay, but what if they are of different versions? Making all crates in the workspace use the same dependencies means the crates will always be compatible with each other. Let's add the rand crate to the dependencies section in at1 cargo.toml file, so we can use the rand crate in the at1 crate. So go to add1 cargo.toml, add1 cargo.toml, add1 source cargo.toml dependencies. So does it mean that only add1, whatever you have here in lib.rs, will be using random generator? We can now use rand to the add1 source librs file. Add1 source librs file. Okay, so it can be added here. Okay. Building the whole workspace by running cargo build in the add directory will bring in and compile the rand crate. You will get one warning because we aren't referring to the rand we brought into scope. Okay. The top level cargo lock now contains information about the dependency of add rand. However, even though rand is used somewhere in the workspace, we can't use it in other crates in the workspace unless we add rand to their cargo.toml file as well. For example, if we add use rand to the other source main rs file for the other package, you'll get an error. Cargo build adder use rand in other source main. Then you do a cargo build within adder source main rs, adder source main rs, then use rand. Okay, so let's just pretend we are going to use rand. Use rand. Okay, and if we go back to adder, cargo build, do a cargo build. This one is under add one. cargo build. Because we have brand inside, add one. That's why there's so many things here. Let's see that we are trying to do cargo build. No, cargo build where? Other source me. Other. So where do we need to do a okay, cargo.toml is here. If you do a cargo build, cargo build. No external crate run. Okay, so now we are at the same page. No external crate run. To fix this, edit the cargo toml file for the other package and indicate that rand is a dependency for it as well. Building the other package will add rand to the list of dependencies for other in the cargo.lock, but no additional copies of rand will be downloaded. Okay, so here we need to include these dependencies, copy, and here you can remove it like that. But it says other package indicating rand is dependency, so we did that. Building the other package will add rand to the list of dependencies for other in cargo lock, but no additional copies of rand will be downloaded. So from here we'll just do a cargo build. Cargo build. So it's unused. It's just a warning. It's just a warning, but it did not do this. Yeah, so it did not do all of this. Yeah, so cargo will ensure that every crate and every package in the workspace using rand package will use the same version as long as they specify compatible versions of rand, saving us space and ensuring that the crates in the workspace will be compatible with each other. If crates in the workspace specify incompatible versions of the same dependency, cargo will resolve each of them, but will still try to resolve as few versions as possible. Adding a test to workspace. Okay, for another enhancement, let's add a test. Add one function within add one crate. Okay, so under librs, I can have a function CFG test, run cargo test at the top level, add directory running cargo test in a workspace structure like this. Like this one, we'll run a test for all the crates in the workspace. Okay, so these are tests. Okay, so I think we are halfway through. We're still installing binaries and extending cargo with custom commands. So maybe let's continue with this on the next day, perhaps tomorrow. Yeah. All right, so let me end here. And once again, thank you so much for accompanying me doing this live. I know we did not do much of programming. It's mainly understanding more about cargo and cargo crate, no, crates.io as of now. Thank you so much.